Thank you for joining this webinar. In the jargon of market research, there are two types of questions: closed questions that ask people to make choices, and open-ended questions where people type or say what they want. My goal in this webinar is to give you the complete guide to analysing open-ended data. As we go along, if you've got any questions, type them into the questions field in GoToWebinar. Everything I'm going to show you today is going to be in Displayer initially, but then I'll go and show you how to do it in Q, which is our other product. Everything can be done in both products. I'm going to start by describing the goal of text analysis. I'll then look at the concept of machine understandable text, which is really important. Then we'll go into the main sections. We'll start by looking at how you can quickly summarize text data. Then we're going to look at how you can accurately summarize text data. And then we're going to put them together to look at how you can quickly and accurately summarize text data. One of the biggest challenges with text analysis is that often people have the wrong goal in mind. Maybe they've asked people what they like about their phone company. The mistake to make is to think that you want to summarize data like this as a cool visualization. Maybe you're thinking you want something like this. But don't take my word for this being a bad data. Have a look. What does this visualization tell you about why people like their phone company? I think it says the service is key, and the service is linked in this data with being good, great customers, maybe better price and coverage. Is that what you're taking out of it? It turns out that the correct approach was invented before the term text analysis even became popular. Text analysis is the middle step. The objective should be to summarize text as one or more variables, either categorical or numeric variables. That is, to use the jargon of market research, and jargon irritates every non-market researcher, the goal is to code the data. So we take the raw text and we turn it into standardized text or standardized data, categories and values. Having coded it, we then analyze it just like any other data. Here's my analysis of the data that we've been looking at so far. Take a moment to see what you can conclude from this. It's the same data as before. Do you remember before we thought that service was key? Whereas this chart is telling us price and reliability are by far the most important things, but not really things that came up on the previous analysis at all. Why was that? Well, the earlier type of visualization was cool, but entirely misleading. You see, it was just trying to show us which words were networked or closely related with which other words. And service appeared in the middle because it was a well-connected or well-networked word, rather than because it was an important word. The real problem to solve isn't coming up with cool visualizations, it's finding the most efficient way to turn your text data into numbers or categories. If you know you're going to do text analysis when you've collected your data, you should actually take the time to collect what I'll call machine understandable text. Let's work through this. Consider how you talk to a chatbot, Siri, Google Home, or Alexa. Do you talk like this? No, you don't. You understand it's going to cause you a problem. So instead, you talk like this. Linguistics refer to such a simplified communication as pigeon. You'll get better results from text analysis when you try and collect data in pigeon. When I started off in market research, it was good to ask truly open-ended questions, like question 2 here. A person can answer this saying whatever they want. There's no constraint. And that traditionally is thought to be a wonderful open-ended way of collecting data. But a computer does a much better job at a more focused question, like the second version of question 2. And a computer will do an even better job at summarizing even more focused data, like this third version of question 2. Am I saying that we need to always ask questions like the question 2 on the right? No, I'm not. It's a trade-off. But the closer we get to questions like this, the easier it is to automate their analysis. So keep in mind, the trade-off we're making is we can ask more focused questions to have more efficient automated analysis. But if we want to go completely open-ended with little focus, we're going to probably need a human being to do a lot of the heavy lifting of the analysis. There are three big choices, or three big paths we can choose when we're doing text analysis. We can go for a quick summarization of text data, or we can go for an accurate summarization data, or we can try and do both and sacrifice a bit of each, going for quickly and accurately. We'll start with looking at quick analysis of text data approaches. I'll illustrate this with one of my favorite case studies. We asked people how they felt about Tom Cruise. And I've got to warn you, it's a bit shocking to some of you, some people don't love him. I've deleted the most offensive comments. Now, we've actually had a bit of debate internally about this example. Some of my colleagues are a bit concerned that this example might offend some people out there in the market. I love the example because it actually really clearly demonstrates how the text analysis techniques work in an example. It's really easy to get your head across, doesn't require any specific knowledge of an industry or anything. But if you are personally offended, please tell me and I will start using a different example. So the question we asked is, what don't you like about Tom Cruise? So it's a reasonably specific question. What is it about Tom Cruise that you dislike? And this is what people told us. Now, the classic fast way of analyzing this data is to go with your good old word cloud. Now, word cloud is often a step forward to just presenting the raw text data straight to the client or your stakeholders. And ours are actually kind of cool. I can resize them. I can take words that I think are uninteresting and remove them. I can merge together categories. I can create phrases. While those things are reasonably nifty, at the end of the day, this is a pretty simplistic way to be analyzing or presenting text data. An alternative is to create a network diagram like the one I looked at before, and these do look cool. Lines show the strongest relationship. In the 20 odd years since I first saw one of these, I've actually never seen one that provided any insight with market research data. Look at this one. Tom is linked with Cruise. Got it? So now you can applaud your computer for being clever enough to work that out, or you can say, did I need a computer to tell me that Tom was Cruise and he was liked, which is the next big thing. A word map is a bit like a word cloud, but words that appear together in the raw text are placed closer together. I used to like this a bit, but the newer techniques, which I'll get to shortly, are just so much better that I do not use this at all anymore. Gone from my armory of tools. The most common approach when people use machines to summarize text is they just go through and they summarize how frequently different words appear. And there's a few little ways you can improve this, right? You can have your algorithms automatically ignore capitalization. They can fix spelling mistakes. They can get rid of uninteresting words like he, at, and the. They can find synonyms and merge them together. And there's lots of options for customizing this. We've got a tool which does this too. And if you look here, it tells us the word nothing is the most common, followed by like, followed by don't. Again, not really that insightful. A slightly more technical variant of this is to find something called n-grams, which are sets of words that appear together. And so I could tell it, at the moment I was just looking for single words, I could say, look, find groups of up to 5 words and see what you can do. And here it's found that Tom Cruise is one phrase in the data, good actor another, don't like is another. So again, it's just too superficial to be useful. It's my general conclusion that this is the case with this type of technique. We need something better, something like this. Now, if you haven't used displayer before, Q before, you can search at the top. So I want to do text analysis, and then it's going to guide me. And it sits in the advanced analysis menu, text analysis, and there's various bits within here. I'm going to choose automatic categorization, and we've got 3 approaches to automatically categorizing text data. We're going to start with for unstructured text. And I'm going to drag across my data of what don't you like about Tom Cruise, which in this case is sitting in a little spreadsheet. And it's going to take about 30 seconds to do it. It's doing some really heavy lifting in the background using something called an automatic sentence encoder developed by the good folk at Google. Here's one that I've done before, so we don't get too bored. Now, I set this to 5 categories. That's an input. You have to choose how many categories you want. There's no way of automatically doing it. Well, yeah, you can create an automatic way, but it's just not very good. Refer back to segmentation webinar for more on that. So now, as you can see, it's got these 5 segments and it's actually named them. And the first name is a curious one. It says they're arrogant, or that vertical line says, or they not, didn't say not. And here's an example. He's gone off the deep end. Let's have a look. So we can see that this is grouped together 35% of the data points, respondents in the study. And they've said things like he's stuck in himself. He doesn't seem very genuine. He thinks he's too cool, his ego. He's apparent, whether real or not, arrogant, Scientology, loves himself. So the thing that you can actually see is the algorithm has done a really good job at grouping together similar meanings. Now note these aren't similar words. His ego and he's stuck on himself, they're the same concepts, but they're not the same words, which is pretty cool. It's not perfect. It's a quick technique. So it's put that he left Nicole Kidman. Now, for those of you who don't know, she's an Australian actor. The country was affronted by Tom's decision to leave, but it doesn't really mean arrogant. Similarly, he's nice, clearly doesn't mean arrogant. So there's a bit of error. Quick, but a little bit dirty. Another example to look at is the faith segment. So it says faith. It's got a pretty good name for the segment. And you can see here it has a whole lot of things. It refers to Scientology, religious views, his church. And so again, the algorithm has figured out the meaning of the data in the background, which is kind of cool. Now, having automatically categorized the data, what we can do is we can save it as a variable into our data file, which I do by clicking this little button over here. Pops the variable into my data file. And now I can analyze it just like any other data. So here I've got 2 tables looking at gender and region. I'm going to replace the summary here with the categories that we just created. And we can, quick as a flash, see that the faith segment skewed towards being female and in the Midwest. So we've very quickly got some analysis of the text data. Definitely better than a word cloud, but not perfect. And we'll return to that. We'll get to perfect or close enough. I think this is quite magical. On the left, I've got hotel reviews data, and this is in multiple languages. I've got some French, I've got some German. I think some of this is Chinese. I did study Mandarin at uni, but I failed, so don't take my word for it. The cool thing that it's done is it's summarized and analyzed it and presented the results in English. So it's a really big time saver there, I think. Here's another example. I've got the same data, but I've put the summary coming out into Chinese. So you can work both languages at input and output level, which I think is rather cool. Now, some of the other techniques don't have an explicit language translation built into them, but we've got a language translation feature in both Displayer and Q. And so you can just go into ready-made formulas and you find translate text. And if you're using Q, just click in the search box at the top of Q, translate, and you'll find that option as well. For this example, I'm going to use some tweets. The same analysis could be used with open-ended questions, but the Twitter data here will make it quite easy for you to see what's going on. The type of automatic categorization that we just used on Tom Cruise data looks for the strongest patterns in the data. An alternative technique is to use entity extraction. What this does is it searches the text for recognizable or known entities, to use the jargon. Here's an example. The first column shows the tweets. The next column just shows any names that could be found. So the algorithm's gone through and it's tried to work out which text was, words and which were names, and pulled them out as a new variable. It's pulled out URL data, pulled out geographic data, time-based data, and organizational data. And if you want to do this technique, it's in advanced analysis, text analysis, again, automatic categorization, and it sits there as entity extraction. The best example I've seen of this in a real world situation was with customer satisfaction data, where one of our clients had a whole lot of data showing satisfaction and then the names of the service reps in that data. Now, that's usually a bit of a pain for coding because you've got to kind of read through it all and manually put each of the service reps out as a new variable to understand who was doing badly. But this just allowed us to, quick as a flash, automatically extract all of the names as a separate variable. Big time saver. Another common technique for text analysis that most of you will have heard of before, probably all of you, is to do something called a sentiment analysis. And so it sits down here. Let's have a look at an example I've done before. So sentiment analysis, I actually don't think is a very useful technique for market research, because in market research, we can ask sentiment. We can say, how happy are you? How likely are you to recommend? Or how satisfied are you? Which is a very accurate measure of sentiment. But if you're not in that position, you need to extract sentiment. The way sentiment analysis works, it's really a very crude technique. It just looks through the data and counts up the number of positive or negative words. So sentence 1, it's got the word enjoy. That's 1 positive. Compare that to the 5th bit of data. Crazy, somebody decided was a negative word. Distort, negative. Dishonest, negative. So it's got -3 negative words. If it said happy at the end, it would have been -2 because we sum the difference between the positive and the negatives. We're going to get to the most technical part of today. If you are familiar with factor analysis or principal component analysis, you will love what I'm about to show you. If not, I'm afraid I'm going to confuse you for a few minutes, and I'm sorry, but we'll get back to normal broadcasting in a few minutes. Now, sentiment analysis is what's known in the world of measurement as a confirmatory technique. We assume that the people differ in their sentiment, and we seek confirmation of how they differ in terms of their sentiment, measuring it or extracting it from the data. Exploratory techniques instead make no assumptions about what's interesting and just try and find the strongest patterns in the data and share those patterns with us, the data analyst. The exploratory equivalent of sentiment analysis is a technique that we've developed called principal component analysis of text. And we're going to start by just looking at a single component, and sentiment's a single component, positive, negative. Now, this technique, like with automatic categorization, is sitting in the text analysis subgroup, and it sits in the advanced subsection, and you can see principal components analysis of text. Like with the automatic categorization, insert onto my screen, I drag across my text data, and it's going to take a little while to run. It's doing some very heavy duty work. So again, I've got one that I've done before. Now I've set this to show the technique to a single component. Again, it's a decision you make. And text analysis is not like other aspects of factor or principal component analysis where there are good rules to tell you how many components. It's always straight judgment, I'm afraid, with the principal component analysis of text data. So if I've got one component, it's telling us that this one component measures how much people differ in terms of whether or not they said nothing versus didn't say nothing, and correlated words with that. Here's a more interesting one where I've extracted 5 components from the data. And again, I just looked at 3, looked at 4, chose 5 because it seemed to make a bit of sense to me. Now, having run that analysis, I need to save the underlying dimensions. So I've done that by clicking down here, and they'll appear as variables in my data file here. And I then need to give them names to interpret them. So I read down through this table here, the loadings plot, and it tells me what component 1 is. And I can see that these are all negative numbers. And that again relates to nothing, which we actually saw as our first component with our single component dimension. So it's got a quite strong underlying thing of the extent to which people said, in this case, not nothing. Our second component is the extent to which people said Tom Cruise. That's a key variation between people, whether they said Tom or didn't say Tom. The third key dimension that's extracted from the data is the extent to which they refer to Scientology or synonyms for faith. Scientology, so I'm going to call this segment, not segment, this variable component, Scientology. The fourth component that's extracted is people who said actor, who said good, proud, good actor. Okay. Now, they're negative numbers here, so it's not a good actor. And the fifth component is people that have said variation in the extent to which people said crazy and similar words. All right, let's get a little closer into this. And as I said, for those of you who aren't familiar with this kind of types of analyses, don't worry, we'll be back to more easily understandable stuff quite shortly. But let's look at the actual 5 variables that we've created in our data file. So if we look at our first row of data, the person said nothing, I really like him. Now these 5 components give each person on average a score of 0. And so the further the value is different from 0, the more we can learn about that person. So if you look at this first person, most of his numbers are relatively close to 0, except for this very first thing, he's got a strong negative score, which is not nothing. So double negatives mean he said nothing, and we can indeed see that's what this respondent did say. We can sort these components to get a better idea of the patterns. So we can see that if the person has got a negative score for Tom Cruise, this is the kind of stuff they've said, and it's because they didn't say Tom Cruise. The people who've said Tom Cruise have got high scores on this variable. This third component here, Scientology, negative scores, not mentioning anything to do with religion, positive scores, mentioning things to do with Scientology. So that's the underlying data that we've created. And you can then feed that into any other analysis. For example, last week I fed this type of data into segmentation. But back to less complicated techniques. So we looked at the techniques for quickly summarizing the data. How do we accurately summarize the data? The traditional approach in market research is, as I mentioned before, referred to as coding, which involves reading through all of the text data and using our brains to put it into categories. Now, there's a special kind of variant of coding called backcoding, and some people who are new to market research haven't come across it. So I'm going to quickly describe it because it's actually a very useful little technique. The way backcoding works is you've got a question like this. We've asked people what racial group you're in, and because you can't list everything, you give them an other category where they type stuff in. And you find that the stuff they type in sometimes is new data, but really sometimes it's just stuff that's should have correctly been in one of these other categories, and the respondent just didn't work it out. And the way you deal with the backcoding data, the way you do it in our software, is you click on the text data, then you go into, hover the little plus button, go down here to text categorization. You're going to go manual in this case. They're overlapping categories because people are allowed to be in multiple races. Create a new categorization. Then I hit down here in backcoding, hook it up to my race data. And then I just click on this first one, Eastern European. Well, I'm calling that white. And what this does is it moves all of the text data into my existing categorizations, and I can add new categorizations. Anyway, the key thing with that one is knowing that the possibility exists to backcode the data or do something a little more powerful now. We're going to return to our Tom Cruise data. We've seen how we can automatically do it. What we're now going to do is manually categorize the data. So we go into here, we click text categorization. We're going to go manual. Now, when we're analyzing text data, we have to make a decision. Do we want to force each text response to be in one and only one category, mutually exclusive, or to use the jargon from questionnaires, single response? Or do we want to permit there to be multiple categories, each person in multiple groups? Now, often multiple groups is the most accurate way to summarize data, but it takes a lot more time because you've got to make a decision for each group. Are they in it? Are they not in it? Whereas when you choose single groups, it's a more efficient approach because you're pushing people into one and only one group. So it just saves time. So it's a decision to make based on the data and what you're trying to achieve. I'm going to choose mutually exclusive categories for this data because it's just going to be faster to show you. Now, this is exactly the same in Q, and I'll show you that shortly. So how do we do it? Well, in this case here, we've already got a bit of an understanding of how this data works. So ordinarily, you would read through your raw responses and form a view on what the groups were and add them in here. But we've got some theories already, so I'm going to just type in what I think of a sensible categorization based on what we already did with the simple exploratory techniques before. So the way that you manually categorize data is you just read through all of the unique responses and put them in groups. So this first person said nothing, I really like him, so I put him in the nothing group. He leaves this list. The next person says he's stuck on himself, I call him arrogant. The next person says religious views, religion. The next person said nothing. Now I say person, 28 people said this. So this is a big time saver. I push them all into that group at once. Now, traditional coding, a lot of our clients use our software just for this. They read through it all one by one and put them into brackets, into categories, and it's a very efficient workflow. But sometimes you're in a bit of a rush and you want to speed it up. And often you're in a bit of a rush, really, aren't you? And so there's a cool little technique called fuzzy matching. This is really something that we call semi-automatic categorization. And what fuzzy matching is going to do is you can search for a word. And so I'm going to tell it to search for religion. And it's going to search through the data to find religion. Now, it's going to take a little while to warm up, so I'll quickly show you a bit of Q for the Q users out there, showing you how we do this kind of things in Q. So in Q, we have our create menu, which is where we kick off analyses, and it's got text analyses, and these are exactly the same subgroups or categories and options that we were looking at in Displayer. And when we go into them, so unstructured text, for example, you will see that it's in fact pretty much, well, not pretty much, it is the same options exactly as Displayer. So everything I've shown you so far, exactly the same between the two products. It's just how you kick them off is different. When you want to do the text categorization or the coding, you go to the variables and questions tab, you right click, insert variables code. So it says code text because Q is more targeted at traditional market researchers, and so we're using a bit more of the traditional language, whereas Display is used a bit more broadly, so we use the more general language categorization. But once you're in here, exactly the same options. And if I go into it, exactly the same user interface. It's telling me here that's recovered one I did before when I forgot to save, so I'll click discard. And so you can see exactly the same. Back to Displayer. Now, in the background, Displayer has sorted all of the data related to the word religion. It took a little bit of a time because it takes time to warm up. It's actually building some complicated models in the background, but it reuses them, so it's faster. So the first responses are just people that have said the word religion. That's not particularly magical. But if we scroll down, you can see these orange bars. The width of the bar is how similar the phrase is to religion. And you can see here, this person hasn't said religion, they've said religious. And the algorithm in the background worked out they mean the same thing, not so hard. But here it worked out that faith and religious meant the same thing. Here it worked out that a Christian Scientist was a faith, therefore religion. And so you can see it's actually gone through and it's been kind of cool about how it's identified a whole lot of stuff. Now, if I was a very rigorous researcher with a bit of time, I would read this a bit carefully, but I'm just going to be a bit fast and go, well, these are all religion, 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 religion. Boom. They're in the religion bucket. In no time, I've categorized 42 people as being religious. Not 42 people, as saying religion. What about crazy? Now, a question that often comes up is, will it always work this well? Well, it depends how good your data is and how clean the patterns are. So if, for example, I was using a word like service and I had data on telecommunications, there's an ambiguity. Does somebody say service refer to the service of the network or the customer service? If the data is vague, the algorithm is going to struggle. That's just life, I'm afraid. But as a human coding, you also struggle with that data. Now, crazy, so again, we've got a whole lot of stuff exactly crazy. And then we've got stuff, which seems to be similar to crazy. Here we get down to, he's a weirdo. So I'm going to put all these one crazy. The next few responses relate to arrogance. So we'll look at arrogant, sort again. So we've got a whole lot of people that said arrogant, cocky, phony, is that arrogant? I don't know. Full of himself, egotistical, inflated ego, stuck up, maybe, smart ass, full of himself, better than no attitude. All right, put these in the arrogant box. Let's look for nothing. Actually, you won't look for nothing. We'll look at another technique. So fuzzy matching, you search for a word. But once you put stuff in categories, you can actually get display to, in the background, build a model predicting which category things should be in. So there's enough data here, the display can start to train a model to say, okay, who should be in the nothing group, just based on looking at the patterns of what I've done before. And so if we scroll to the top, we can see it's found all of these people have said nothing, nothing, nothing. Here's an error, right? It thinks everything and nothing is similar. And you can understand why a machine might think that. And this is why our human brain comes in time. So, put these into nothing. If we look at religion, so again, it's done a great job of finding more stuff about religion. Crazy. Arrogant. And I can keep reading through this if I want to, but I won't bore you with doing it all, but hopefully I've shown you how fast this was. Now I'll chuck it into other, save categories. And so having categorized my data and done it in Displayer, I can then just use it like another variable's created, and I can use it like anything else, drag it onto the screen. I've got a table and I can then cross tab it with whatever data I have. But you're thinking, well, I like that, but what if I want to quickly and accurately summarize my text data? And yes, you can do that. So using a bit of the jargon, we want to code new data by predicting manual data. That is, the workflow here, if you want to be quick and accurate, is first use either manual coding or semi-automatic categorization to come up with a categorization. Say, let's say it's using 10% of your study, if it's a big study. Then you use a predictive model to automatically categorize the remaining 90% of your data. This is particularly useful in trackers, right? Your first wave of your tracker, you do the manual categorization rigorously, and then you just get the algorithm to put people into buckets for the remaining category, the remaining things. Just if you're doing that, just take care every now and then to have a quick look at the data and just check that no new categories are formed, because this kind of predictive modeling can't discover new categories very well. So how do we do it? Well, we just do the automatic categorization exactly as before, but we then do a manual categorization. We link the two together. And so here where it's got existing categorization, we just drag across this variable of that categorization that I just manually did. And this one is going to take a little bit of time to compute, so we're going to come back to it, but it'll be worth the wait. Case study 3. In market research, we often ask people to type lists into boxes. For example, what cell phone company can you think of? And you get data like this. This type of data is much more structured than the examples we've looked at before, and this structure makes it quite straightforward for algorithms to automatically categorize it. And so when your data is like this, we've got a special techniques, or set of techniques. I go into text analysis, again, automatic categorization, but this time list of items. I've got some cell phone data on spontaneous awareness, drag it across. And now it's searching through and finding all of the common bits of text. And I can have either one variable with commas, or I could have multiple variables, and I can group them together. And so what you'll see is it's now found that the most common thing in the data was Verizon. And if I hover over it, it's done a whole lot of clever things. So it's ignored capitalization, it's taken these different spelling mistakes into account and all these weird ways of doing it. And it's actually found 18 different variants of Verizon and it's grouped them together. And so that's a lot faster than a human being trying to categorize it. Now, with this type of algorithm, you've got to be a bit nervous because sometimes if you make the algorithm too aggressive, it can group together things that shouldn't be grouped together. And so we've set this up so you've got to manually give it some information in some situations. It doesn't want to be too aggressive on its own. So, and that means that sometimes it misses stuff. So you can see here AT&T and @ the algorithm wasn't confident to combine them. So it's got 19 variants of AT&T and 8 variants of this other brand called @ Similarly, T-Mobile and T-Mobile, the algorithm wasn't confident enough to group them. And so we tweak it. We go down to the required categories group and we tell it that we definitely want a category called AT&T, and that when we see @ and things similar to @ put them in there. We definitely want a category called T-Mobile, and when we see T-Mobile or things similar to that, we want to put them into that categorization. And there are lots of other options for tweaking this type of thing, and it really just comes down to how thorough a job you want to do. Now, once it's updated, and you can see here, we've now updated, and AT&T is now a number 2 brand. Just like we did with some of the other things before, I go down to save variables here, and I tell it to save out. In this case, I'm going to choose my first category because I'm creating top of mind awareness, to use the jargon. A new variable appears in my data file. I can then drag it onto the screen. And a common question we get into support is, if I've got spontaneous awareness data, how can I create a word cloud? Well, there's 2 steps. You firstly use the automatic categorization to tidy it up and get rid of all the different spellings and things. And then you just go down to word cloud. And now we have what is a relatively good word cloud in that each of the brands only appears once and the size is proportional rather than there being 1,001 spellings, or 18, I should say, spellings of Verizon in the word cloud. Now, the real power, though, isn't with simple techniques like word clouds, it's with standard crosstabs. It's when you drag across the automatically categorized data, then you say, look at interview date, and quick as a flash, we've worked out that Verizon was lower in July and then picked up in the following 2 months. Now, before we got it to automatically categorize some data, and it's finished doing that, I clicked on the wrong one, wrong one again. So before we got to do it now, it's actually built a predictive model, and the details are in the little footer of the table. So I'm just going to zoom in a fair bit here and have a little closer look at it. So it's telling us that it's taken the 299 cases that we used and built an automatic categorization, which was 100% accurate. So the model was able to 100% of the time correctly predict which manual category someone should be, which would hopefully tell us that when we categorize new data, it would be 100% accurate. But those of you who are familiar with predictive modeling will know that it's always easier to predict your data set that you use to create the categorization with your model, and you tend to overfit. The better thing to do is to do something called cross-validation, where you say build a model with 50 of your responses and predict the other, in this case, 249 responses. And you can see here, this is exactly what I've done. And so the algorithm in the background said, okay, if I only coded 50 people, how accurate could I predict the other 249 people? And it says I'd accurately predict 73% of the time. And we can see that when we get a bigger sample of 200, it's actually predicting 87% of the time. And so presumably with all 300 people, if we had new data, would be even more accurate than that. I say presumably because you don't know for sure, but this is information used to make the trade-off. Common question I get here is, can I guarantee that it's going to be this accurate? No, you can't guarantee it. There are 2 things required to be accurate with this kind of automatic categorization. One is that you've done a good job with your manual categorization. If you feed it a bad categorization, then it's impossible to build a good model. And as an example, let's say that Scientology was categorized in one segment, but Scientology just in a second segment, the chance of an algorithm being able to detect that nuance, unless it occurs a lot, is really small. So that kind of error in the categorization will just make the modeling inaccurate. Secondly, there has to be clear structure in your data. So market research data where you've got a very specific question tends to have a very clean structure, so predictive models work well. Twitter data, by the other hand, tends to have very little structure. Anything can be in there, which means the models predict badly because there's just no structure for the models to attach themselves to. Whew. All right, here's an overview of everything that we went through. We will send you a link to a recording of this webinar later in this week. If you just want to look at this slide, you'll have to scroll to the end of that. What questions have you got? Please type any questions into the questions field and go to webinar, and I will go through them now. And just a little advertisement next week. How to do your own max diff study is what we will be talking about. And Lisa had struggles with audio. Didn't hear anything. I'm sorry, Lisa. The audio did work at our end. We have a few checks on the audio. So it was definitely working, I'm afraid. Jeremy said, will today's session cover both capabilities for displayer and queue? Yes, as we've shown, both capabilities for displayer and queue. Sumya says, can we have network maps in queue or is it just in displayer? You can have them if you want them, but they're not very useful. But how do you do them in queue? It's not that difficult to do. I say not that difficult, but let's have a look. Now, it's not something we put in the menus because we only put things in the menus which we think are good, but the code is actually listed here. And so if you look at this code, it's a little bit verbose code, but you can either type it in yourself, scroll to the right here so you can see it all, see it in this video, or if you really want, send me an email and I will send you an email back with the example. All you need to change in this code to get it to run is in queue, you just need to go copy this code and you would go in queue, create R output, and it will show you an R output where you paste in that code and just hook up the first line of code to show your variable name or question, and then it will automatically create this network. Lewis, hello Lewis. Can a respondent comment be in more than one group, such as the Tom Cruise data? Yes, it can. When you create your categorization, a decision you have to make is, do we go text categorization, multiple overlapping categories, that is, we want it in multiple groups, or mutually exclusive categories? Now, when we go multiple overlapping categories, we then, I've selected some different data. Here we go, this person's talking about price, so I'll create a category here called price. And I put this person into price, they're categorized as, or in this one said discount, put them in price, categorized as. This person said no contracts, which is kind of a pricing factor, and the ability, it's payment terms. So I'm gonna actually just read payment terms. Now, if we go down to this person, they've said payment terms and low rates. So I'm gonna put them in price. Contracts, price. And now, if I go back to all responses, you can actually see here, I've actually show which category I'm in, and now I can start going through it. I'm saying I'm going to add this one here to also to the price category. And so now you can see they're in 2 responses. And I can still do all those fuzzy searching and algorithms that I showed you before here as well. But just when you're doing multiple categories, it just takes much more time, but it can be a more useful granular view of the data. Dido says, to apply textual analyses, must data necessarily be in spreadsheet form, or can we upload a series of PDFs to Displayer and have it search text in them? I'm sorry, Dido, Displayer really wants you to have your data in a more structured form than a PDF. You need to ideally have them in a high quality data file, like an SPSS file, SSS file, but failing that, you need to get them into a spreadsheet and spend a bit of time structuring the information a little bit neatly. The reason for that is, if you were to import the PDFs, you just have to spend so much time in Display telling it how to find the data in it. And so we think it's better to just focus on structured data. Nicole says, Hello, is this available in the free download version? Yes, it's all in the free version. You will get time clocks and warnings if you've got large data files, and it'll say you'll need to buy, but if you've got small data files, you can do it in the free version for sure. Santiago says, how to do an analysis of more than one variable, for example, motive 1, motive 2, etc. So going back to the techniques, and so with the categorization, I'll show you the spontaneous awareness. Oops. With the spontaneous awareness categorization, the box actually is set up to allow us to choose multiple variables at the top. If we were doing the categorization here and we had multiple variables, we could literally just select both of the variables and then go in and do the text categorization, and it would perform them on the multiple variables simultaneously. If we wanted to have a joint code frame and reuse something we've previously done, what we could do is we could first categorize one category thing, and then we do reuse an existing categorization, then it shares them. And the last option we've got is you can export a code, a categorization, and reuse it in a different project to save a bit of time. And Ken says, did you say Google created the AutoCAT algorithm? Not quite, I may have said it, but I didn't mean to. So Google's created these wonderful algorithms which find structure in text data, and the way they work, and they're called, the one that we use is called a sentence encoder. What it does is it takes any data and it turns it into a massive 512 variable data analysis. We'll call it tensor, and we then use that and munch that in the background with our own algorithms. Things like clustering and things like that. Joanne says, what if you have a list of codes from a previous study? How do you incorporate that into a second session? Yeah, so what you do, having done your categorization, we'll go back and I mentioned this very briefly in passing just then, but we'll go back in and we'll modify that categorization we did before. So let's say that you've done this categorization in one study and you've got another study and you want to reuse it. All you do is you go export and it'll remember all the text responses and automatically categorize anybody who, based on the same data, and it will use those categorizations when it builds its models in the background too. Carl says, can we get the slides in addition to a link to the video? Yes, we will send you a link to the display document, which you can then export as a PowerPoint or a PDF. Ron says, Jonah says, I do this in Q, not display. Well, you can do it in Q, not display. It'll all work exactly the same. It's just display is nicer for presenting. Ron says, will a recording be available? Yes, certainly. He then says, we've been using Q for text analysis, but you've broadened my understanding, so that was helpful. Good. Pleased to hear that, Ron. And he also goes on to say, when doing automatic coding, must you always start with a manual coding first? When to use the automatic? So there's a trade-off you have to make here, and it comes back to right at the beginning of the webinar. Are you in a rush? Your client's not prepared really, or your stakeholders don't want to pay for you to spend the time to manually go through it, then you use the automatic categorization. Sometimes gold, sometimes garbage. If you've got time, you always want to do that manual or semi-automatic categorization that I showed you and use your brain, because your brain is always better at text processing than a machine. Machines are more consistent, but your brains are much more likely to find the patterns because they've got the context that's relevant, and context is king. If you want to be quickly and accurate, then you want to combine these two things, so that as you first want to manually categorize and then use the automatic algorithm. But you only need to feed this manual categorization into the automatic categorization if you're trying to be quick and accurate. Richard says, hello, Richard. If you have auto-categorized data, can you then shift responses between categories if they don't seem accurate? Yes and no. Does the user interface make it easy to do? No. Can you do it by just modifying the underlying variables? You certainly can. And if lots of people ask us for that, we'll end up building the feature. So when we send you those NPS surveys, that's the time to tell us, or send me an email. Rich also said, nope, we've done that one. Ron says, I know you can use the same code list across more than one survey, say across multiple countries. Is there any size limitation that could become a problem for use for several studies or over long periods of time? In truth, I don't know we tend to only find those kind of limits out when customers do stuff that we'd never have imagined. So give it a go, Ron, and if it breaks, it's our job to fix it. And if it's on a live project, we'll try and fix it really, really fast for you. Blair says, is there a way with spontaneous brand awareness to determine which brands were mentioned first, second, and third? Yeah, there are two ways you can do this. And let's go and have a look at it. So before you saw me extract out the first mention data by just choosing the first categories, and that got the first mention out. If I click the categories button, and this could about to make my computer go very, very slow. What it's done here is it's automatically set these as, and so this is just showing any, you can see here it's got, this is the first mention in the first thing, second mention in the second, third mention in the third, and so on. You can see it's sitting there with a type binary multi-compact in the background. So yes, is the short answer. And you could then duplicate or split these up or do whatever you liked with them. Paul says, hey, I've done the automatic categorization queue. Most of the time it gets it right, establishing categories or so and placing responses correct. Sometimes it does not. Is it possible to dive back in and fix that? Look, well, sorry, yes and no. The way you would do that is you would, if you're happy with some of the categories, you then create a filter of the ones that you weren't happy and rerun a second categorization or some kind of analysis on the data that was bad, and then combine the two together as two variables using a little bit of code to join them together. Or maybe instead just do them as a banner to combine them together. That was how you would do it in that situation. It'd be a little bit fiddly, but you can definitely do it. And hopefully I've answered all of everybody's questions. Look, for all of you that have joined the webinar, thank you very much. For our queue customers and display customers out there, thank you so much for being our display and queue customers. And if you're not one of our customers, hopefully you've seen how much time we can save you. Anyway, enjoy the rest of your evenings or days. Bye now.